What's another thing we did very, very early in the course? Something I kept nagging you about for the whole course and still will. Basic functions, right? I'm not going to list them. You should know what they are. You should know how to graph them. You should know what the graphs look like. If I say graph of a natural log, you should have done that so many times you can immediately visualize the graph and some of the details. If you're not good at visualizing, well, at least you can write them down, make a picture of it. So you have the basic functions, okay? And you can graph them quickly, right? What else do you do with basic functions? In the flow experiment, do you get a basic function when you graph the data? Do you get something that's related to a basic function? What basic function is it related to? Okay, well, you need to know. And you need to know that the pendulum model is related to your general power function, right? AX to the P is a power function. Okay? What's the formula for the function? Is it like y equals x squared, y equals x cubed, y equals 1 over x, y equals square root of x, etc.? It's one of those. Well, okay. It tells me you need to have that scheme in mind, and I'll make sure I continue to address this. These last couple of weeks we were trying to pull everything together and see how everything fits together, right? Okay? You need to know this. You got to know transformations. And you got to know that A f of x minus h plus k means what? If you know what f of x is, how do you get this? Okay? Totally essential. Domains and ranges, and not just of the basic functions, but first of all of the basic functions. You gotta, if I ask you to write me a paragraph on this, you should be able to write me a succinct paragraph explaining what all these things mean and how to do it, okay? I'm not going to ask you to do that, too much writing, I don't want to injure your arm, okay? But if you can't do that, then there are things that you're probably not going to be able to do on the test. Okay? Important things. Composites. You've got to know how to do a composite and find its domain and range. I give you two functions. What's a composite? If I give you a composite, what are the two functions? Okay? So, you have the complete text. You can review that. You can, look at the chapter summaries. You can look at the sections for details. You can look back at the videos. You can look back at your notes. You can look back at your homework. Okay? I'm not going to be able to summarize every detail of the whole course by trying to give you the overview. Okay. So, now we'll go into more detail on some of these things. But again, within the time we have today, I'm doing what I think we can do. Okay, so you got to know all these things, what they mean. You've done a lot of problems, and on the whole, with this stuff, you've done fairly well. Ranges are a little bit of a problem. a little harder than domains. Okay. Domains, what do you do to find the domain? Well, first thing you do is you see if there are any denominators, any values that make the denominator 0, because you can't have those in your domain, right? You can't have numbers in your domain that don't work in the function. You also can't have a square root of a negative number. And you couldn't have a log of a negative number. But if you know that much, you're probably in fairly good shape if you know how to identify those things. Okay, well, there we have it. Okay, you got this stuff. That was early in the semester, but it didn't look too awful bad on the midterm. Hopefully it'll look even better on the final. Okay. Now, coming back to an example. Vertical stretch by factor A. Horizontal shift negative B over 2A. And a vertical shift F of negative B over 2A. Which just indicates that once you know what your horizontal shift is, that's your axis of symmetry, you plug that coordinate in to find the y value, and that's, if this is an f of t function, that's f evaluated at your axis of symmetry. That gives you the y coordinate of your vertex. Again, something that you knew at least for a little while, most of you, at the midterm, okay? So, a little review on that, and you should be okay. You might not totally understand it with this notation, but you want to get to where you do, because that means you understand it a little better. Now, that's okay, but what basic function are we doing this to? Well, we're going to digress and do a couple examples. Let's say it was 1 over x. Okay? So, y is 1 over x. These transformations give us a f of x minus h plus k for a equals little a, h equals negative b over 2a, and k equals I'm not going to write that down right now, because I'll do it in a minute. So, y equals a multiplied by what? What's f of x minus h if y equals 1 over x? And let's make it t, because that can be confusing as a function of time. Okay. What's f of t minus h? But here's your f of t, right? Okay, so let's be sure we understand that the function is 1 over t, so your f of t is 1 over t. Probably should have said that. So it's going to give you this, where f of t is 1 over t, right? So if f of t is 1 over t, what's f of t minus h? Well, I'm not going to wait around. It's 1 over t minus h, and you should know that because you just, if you want f of t minus h, then you take t minus h and plug it in for t. I've said that many times, you really need to internalize that. Okay. Well, there's no way that's going to be of this form, is there? You got t in the blame denominator. It's not going to be in this form, right? Well, 1 over t is a perfectly good basic function, or 1 over x, doesn't matter what you call the variable. Okay? Perfectly good basic function, but it doesn't lead us to the form of a quadratic function, does it? So we're going to take a guess as to what function we might want to use? Okay, well, look for the question in your homework. I'll give you 3 choices. Just do this for 3 different things and see what you get. Okay? Okay. So we'll follow up on that. It's not going to be a hard problem if you know how to plug in to get a composite. Okay? Or how to plug in for function. We're not talking about a composite. So these are properties of functions, and you got to be good with all of this.